Our video today is in Lesson 11, and it's on rate of change, which is a new concept we're bringing into the math class this year, but you have done it in science, so hopefully you'll be able to relate it. And we're going to relate it to the constant of proportionality, which we just had our assessment over. Okay, the first example says Isaiah sold candy bars to help raise money for his scouting troop. The table and the graph show the amount of candy he sold compared to the money he received. All right, so we can look at the table and the graph over here, and it's already set up. And so I'm just going to look at the graph and make sure they've got money received on the y-axis. So I'm going to mark that y. And they've got number of candy bars sold on the x-axis. So that's what they have marked, so that's good. And that means that the money received depends on how many candy bars they sold. So it's going to be how much money they make per bar. All right, so we're going to hold off on this equation. You don't need that yet. We'll come back to it. It says, is the amount of candy bars sold proportional to the money Isaiah received? Well, yes, of course it is. And you know that there's two ways we could look at it. We could say we got a straight line that goes through the origin. So there is a straight line going through the origin, 0, 0, that shows the relationship. I'm just going to say the relation. The other way is we can calculate the unit rates. So I'm going to hold off on this real quick. Let's go back and do the unit rate. So we know unit rate, K, is equal to Y over X. We also know that's equal to the constant of proportionality. But if we change them all to the unit rate, we'll be able to then compare them because they'll all be out of 1. So if we say 3 divided by 2, well, that's 1.5, or 1.5. And let's go ahead and write 1.5 since we're going to be talking about money per bar. So that's like $1.50 per bar. So 6/4, that's also 1.5, or $1.50 per bar. 9/6 is going to be 1 3/6, which is also 1.5, or 1.50. And 12 divided by 8, that goes in 1 time. And you have 4 left over, and 4/8 is 0.5, or half also. So we can also say that it's proportional because all unit rates are the same or equal in this relation. All right, so what is the change from one point on the graph to the other? Now this is the part we're going to call the rate of change. Show the work on the table and the graph above. So the change from one point to the other. Well, we've got the point 0, 0, and we've got the point 2, 3. Okay, so this is the point 2, 3. To go from one to the other in order to get there, okay, our unit rate, well, let's look at our rate of change. So we have to go up 1, 2, 3 units, and then we have to go to the right 1, 2 units. And I know it's 2 units because it counts 1, 2 there, and we're counting 1, 2, 3 up there. So it's all in units of one space when we calibrate it. So that means it goes up, what I say, 3 and over 2. All right, so there's a rise of 3 and a run of 2, up and then left or right, okay? So let's try the next point, okay? The next point is going to be 4, 6. So I'm going to go from 2, 3. So if I go up 3 and right 2. So I'm going up 3 and right 2. And I'm going to start putting a plus sign on there so you know up means plus and right means plus. So then to go from 4, 6 to 6, 9, 6. I'm sorry, from 6, 4. No, I said it right the first time. 4, 6 to 6, 9. We're going to go up 1, 2, 3, and then to the right 2. And that's the same thing that would happen. So for the next one, so it's plus 3, plus 2. So remember, going up and down is on the y. So that is going to be a rise, we call that, of positive 3, and a run means either left or right. We're going to have a positive 2. Okay, so we're going up and right on this one, but we don't always do that, and I'll talk about that later. Okay, so what is the change from one point on the graph to the other? Okay, so the change between each y-coordinate, well, we went up 3, so that's going to be positive 3. The change between the x-coordinates was positive 2. What would be the rate of change? Well, that would be, we set it up just like the unit rate. It would be 3 over 2. Is the rate of change constant? Yes, because every time we go up 3 and right 2. So yes, and so we'll just say yes. Up 3, comma, right 2 units. Okay, what do you notice about the rate of change and the constant of proportionality in this, and it says in proportional relationship, but in this proportional relationship? Well, we know they are equal. So the rate of change, I'm going to put R of C, is equal, well, let's say is 3/2, and the constant of proportionality, constant of prop, is 3/2. So they're equal to each other. All right, and the rate of change, we're going to start calling it M, actually, when it's a constant rate of change. And we already know that we call the constant of proportionality K. So just keep in mind that this is going to be our M, and this is going to be our K. And there's a reason why we give them different letters, but they're really in a proportional relationship. We see right now they're the same thing. Okay, example 2 says graph the points provided in the table below and describe the similarities and difference when comparing your graph to the graph in example 1. All right, so, oh, hold on a minute. Let's go back and look at the equation. I completely forgot about that. Okay, so we know that it's proportional, this relationship, so we can use y equals kx. Or number of candy bars sold, so we could use S for sold and R for received. Okay, so since this is the dependent variable, it'll be R equals, and our rate of change, or our rate of proportionality, is 3/2 times K, or X. In this, we're going to use S. So if you said Y is equal to 3/2 X, that's okay too, because this is the X axis and this is the Y axis. This is the dependent variable, this is the independent variable. All right, so now let's go to this next one. And we're going to look at this equation too, but don't worry about it just yet. Just help me remember to come back to it. All right, so we've got our points plotted over here. So this one is, I'm going to put it over here, 0, 6. So 0, 6 is right here. And then we have 3, 9. And here's 3 in between. And there's 9 going across in between. So there's 3 and there's 9. So that's 3, 9. And then they have 6, 12 also plotted. So here's 6, and then we go over and we find 12 to the left, so 6, 12. All right, so it says, are the x values proportional to the y values in the relation shown in the table, graph, and equation above? Okay, now, when I look at this graph, it's straight, but it doesn't go through the origin. So right away, I can say no, okay? And one way we know is that we have, it doesn't, the line doesn't or does not pass through, I'm going to put THRU period, commas, or 0, 0, which is the origin. Okay, now we can also compare our unit rates over here, so let's do that. So this is y, so it's going to be 6 over 0. Well, we're not going to count that one because it's when x is 0. It's undefined. Okay, so we go 9 divided by 3 because we know y is, I'm sorry, I'm going too fast. K is equal to y over x, and that's what I'm calculating here, the k. So then we have 9/3, that's going to be 3. 12 divided by 6 is going to be 2. So right away, we see that they cannot be proportional because the unit rates, we found 2 of them that aren't the same. Okay, so I'm just going to say the unit rates are not constant, because that's what it means. Are not constant, which means they do not equal each other at some point. Now the rest of them, well, let's check them and just see. Okay, so if we have 15 divided by 9, Nope, that's going to be 1 and 6/9 or 1 and 2/3. And then 18 divided by 12. It could be equal to one of those, but I don't think it is. 1 and 6/12 or 1 and 1/2. Okay, so none of them are equal. But even if we just found 2 of them that weren't equal, we have to say no. And we know that from the graph here. So let's hold off on the equation. All right, it says, what's the change from one point on the graph to the other? Show your work in the table. Now, we still have a straight line, so we can still look at the rate of change like we did on this line. So we're going to do that now. So if I go from 0, 6 to 3, 9, I'm going to go up. From 6 to 8 is 2, and to 9 is 3. So I go positive 3, and then I go right. Well, I'm going from 0 to 3, so that's going to be plus 3. Then I go up 1, 2, 3 again, and I go right 3 again. And I go up 3 again and right 3 again. So since it's a line, the rate of change, which we also call slope, and you've probably heard that in math, is the same. Okay, so what is the change from one point on the graph to the other? Well, it goes 3 on the y-coordinates up, so plus 3. And on the or the x-coordinate, it's going from left to right, and it's going to the right 3. So what would be the rate of change? 3 over 3, which is the same thing as 1. Is the rate of change constant? Yes. Now, notice that the rate of change is constant, okay, because it goes up 3 over 3, up 3 over 3, but the unit rate is not. Okay, now, that's because it is not a line that goes through the origin. It's a line, but doesn't go through the origin. Okay, so what do you notice about the rate of change and the constant of proportionality in this non-proportional relationship? Okay, the rate of change, there is no rate, or I'm sorry, the rate of change is constant, and we're going to call that M, and is 1, okay, and there is no constant of proportionality. There is no K. There is no constant of proportionality. Oops, you can't see that, I'm sorry. There is no constant of proportionality. All right, and you can pause this and rewind if you missed anything. And we're going to go on to the next page now. And the rest of this is a lot even easier. Okay, so it says another name for rate of change is, that's supposed to be slope. And you've probably used that in science class. The rate of change in a graph of a line is constant. Okay, so it's always going to be constant on a line, the rate of change. Okay, this is a line, doesn't have to go through the origin. Okay, so M is what we're going to call it, is the change in the y values over the change in the x values, which is, if you look right here, change in y, we're going up on the y, and there's the change in the x because we're going horizontal. Okay, so that's what they're talking about there. So we can call that y minus y1. You're just going to subtract the 2 y coordinates over x minus x1. We'll come back to this later. This symbol, delta y over delta x, just means the change in y over the change in x. This delta is a Greek letter, and it just means this part right here, the change in and the change in. That's what delta means. All right, so example 3 says your uncle just bought a hybrid car and wants to take you and your siblings camping. Create a table and then graph and explain if the quantities are proportional to each other. All right, now, if you'll recall, this is what we did when we were having our little artwork day where we did the posters. And if we look at these ratios, okay, because we're doing gallons per hour or hours per gallon. Okay, we're doing hours on the vertical axis, and that's the dependent variable. So that's going to be y over x. It's the independent variable x. So it's going to be hours per gallon. All right, so hours is going to be the y, and g is going to be the gallons. Okay, now we know it says create a table and then graph and explain if the quantities are proportional. And I've already graphed it for you, but let's look at the quantities here. We're going to do